Intuitive. Imagine looking down at Earth from space, a beautiful blue marble floating in the endless darkness of the cosmos.
Space begins just 100 kilometers above our heads, where the atmosphere becomes too thin to support adult human life. The Kármán line marks the boundary between Earth's atmosphere and outer space.
Beyond our protective atmosphere lies a realm of extreme temperatures, radiation, and absolute silence.
The vacuum of space means no air to breathe, no sound to hear, only the silent dance of celestial bodies.
From space, Earth appears fragile and precious, a reminder of how unique our home planet truly is.
Looking at Earth from space, national borders disappear there. We see one interconnected world.
Look at that speed.
It never gets old, does it?
The International Space Station is humanity's outpost in space, continuously inhabited since November 2000.
Space stations are assembled piece by piece in orbit, each module launched separately and connected in space.
Solar panels spread like wings, converting sunlight into electricity to power all station systems. Inside the station, every surface becomes useful. There is no up or down in zero gravity.
Life support systems recycle air and water, turning yesterday's waste into tomorrow's drinking water.
Scientific experiments in microgravity reveal secrets impossible to discover on Earth. China's Tiangong space station represents the newest permanent human presence in orbit. Growing food in space requires special LED lights, careful water management, and constant monitoring. Future space stations may rotate to create artificial gravity, making long-term living more comfortable.
Liquid fuel rockets mix fuel and oxidizer in combustion chambers, creating controlled explosions.
Over 8,000 satellites currently orbit Earth, serving countless purposes for humanity.
The Tsiolkovsky rocket equation determines how much fuel is needed to reach any destination in space. Rockets work by Newton's third law. For every action, there is an equal and opposite reaction. Multi-stage rockets shed weight as they climb, becoming lighter and faster with each stage.
SpaceX's Falcon 9 can land its first stage back on Earth, revolutionizing rocket reusability.
Communication satellites relay television signals, phone calls, and internet data across continents.
The Saturn V rocket remains the most powerful rocket ever to fly successfully, standing 111 meters tall.
Solid rocket boosters provide immense thrust, but cannot be shut down once ignited.
Rocket exhaust creates beautiful trails as ice crystals form in the upper atmosphere. Launch windows are precisely calculated based on Earth's rotation and the target orbit's position.
Modern rockets use sophisticated guidance systems, adjusting trajectory thousands of times per second.
Weather satellites monitor storms, track hurricanes, and help predict tomorrow's forecast.
Earth observation satellites watch our changing planet, documenting deforestation, urbanization, and climate patterns.
GPS satellites enable precise navigation, telling us our exact position anywhere on Earth.
Spy satellites can read license plates from space, though most imagery is far less detailed.
Sound suppression systems spray thousands of gallons of water to dampen the intense acoustic energy. Satellites must maintain precise orbits, using small thrusters to counteract atmospheric drag.
Geostationary satellites orbit at exactly 35,786 kilometers, appearing stationary above one point on Earth.
Satellite constellations like Starlink promise global internet coverage from thousands of small satellites.
Polar orbiting satellites pass over the entire Earth as our planet rotates beneath them.
Launch pads are massive structures with flame trenches to redirect rocket exhaust safely.
Mobile service towers provide access to rockets during preparation, then roll away before launch.
Payload fairings protect satellites during launch, splitting open once outside the atmosphere.
Strong back structures support rockets on the pad, keeping them vertical against wind and gravity.
Umbilical connections supply fuel, power, and data until the final moments before liftoff.
Sound suppression systems spray thousands of gallons of water to dampen the intense acoustic energy. Recovery vessels position themselves in the ocean to catch returning rocket stages. Orbital velocity at low Earth orbit is 7.8 kilometers per second, creating a perfect balance with gravity.
Range safety systems can destroy errant rockets to protect populated areas.
Tracking stations monitor rocket telemetry, watching every sensor from liftoff to orbit.
The Oberth effect means burning fuel deep in a gravity well provides maximum efficiency.
Launch control centers coordinate hundreds of specialists, monitoring thousands of parameters.
Escape velocity is 11.2 kilometers per second, the speed needed to break free from Earth's gravity.
Delta V budgets calculate how much velocity change is needed for any space mission.
Japan operates sophisticated satellites and contributes modules to the International Space Station.
Gravity assists use planetary motion to accelerate spacecraft without using fuel.
The Oberth effect means burning fuel deep in a gravity well provides maximum efficiency.
Hohmann transfer orbits are the most fuel-efficient paths between circular orbits.
Lagrange points are positions where gravitational forces create stable parking spots in space.
The rocket equation shows that reaching orbit required carrying fuel that weighs many times the payload.
China has become a space superpower with its own space station, lunar missions, and Mars rover.
Space traffic management tracks over 34,000 objects larger than 10 centimeters in orbit. The vis-viva equation relates orbital velocity to distance from the central body. The United States put the first humans on the moon with Apollo 11 in July 1969.
Russia continues its space legacy with Soyuz spacecraft and Progress cargo missions.
Specific impulse measures rocket engine efficiency. Estimate how much thrust per unit of fuel.
India's space program achieved Mars orbit on its first attempt, a remarkable engineering feat.
The Soviet Union launched the first satellite, Sputnik 1, on October 4, 1957, beginning the space age.
The European Space Agency represents 22 nations working together in space exploration.
Over 90 countries now operate satellites, making space truly international.
The Space Surveillance Network uses radar and telescopes to catalog every tracked object.
Israel, Iran, and North Korea have demonstrated satellite launch capabilities.
International coordination prevents satellites from interfering with each other's radio frequencies.
Private companies like SpaceX, Blue Origin, and Rocket Lab are transforming space access.
Orbital slots for geostationary satellites are carefully allocated to prevent overcrowding.
Conjunction warnings alert satellite operators when objects will pass dangerously close.
Debris mitigation guidelines require satellites to deorbit within 25 years of mission end.
Active debris removal technologies are being developed to clean up dangerous space junk.
Future space traffic systems may work like air traffic control, managing thousands of active spacecraft.
Sputnik's beeping radio signal announced humanity's arrival in space, heard worldwide in 1957.
The Soviet goal was demonstrating technological superiority during the Cold War era.
The first space station, Salyut 1, was launched by the Soviet Union in 1971.
The Space Shuttle introduced reusable spacecraft in 1981, flying 135 missions over 30 years.
The Hubble Space Telescope opened our eyes to the deep universe in 1990.
The Outer Space Treaty of 1967 declares space as the province of all mankind.
Satellites monitor Earth's climate, measuring temperature, ice coverage, and atmospheric composition.
The first commercial spacecraft to dock with ISS was SpaceX's Dragon in 2012.
No nation can claim sovereignty over celestial bodies. The moon belongs to everyone.
Space debris creates navigation hazards that worsen as more satellites launch. Space extends infinitely upward, but national airspace typically ends at 100 kilometers altitude.
Climate change affects satellite orbits as the atmosphere expands with warming temperatures.
Signal jamming between nations can disrupt GPS, communications, and surveillance satellites.
Anti-satellite weapons threaten the peaceful use of space, creating dangerous debris fields.
International cooperation in space remains strong despite terrestrial political tensions.
The future of space depends on responsible management of this shared frontier for all humanity.